And this stuff is detailed on page 770 of your text. They also give you a chart on the top of page 771. The cephalic phase is common sense because I think we all know that as you start to get interested in eating, if you go downstairs and you're really hungry and you smell Chick-fil-A, the smell of that food, the talk about eating French fries or a chicken sandwich or whatever you might think is tasty, that's going to start to increase the secretions of juices in your stomach. So this is what we think of as the cephalic phase. It's what your head is involved in doing to promote the secretion of juices. You'll notice there's a blank there on the bottom of page 93. This is the vagus nerve that helps to stimulate stomach glands. Okay, so we've talked about that vagus nerve. It's a rest and digest parasympathetic pathway here that we're discussing. So it promotes the stomach's activity, and then it, of course, decreases the activity of the heart. I wanted to mention that last bullet point to you. Depression or lack of appetite is going to suppress the cephalic reflex. So, there's another thing here that plays a role, and that's epinephrine. If you're excited, if you're taking a diet pill, those oftentimes contain epinephrine. So those types of issues may also depress the stomach's activity. So epinephrine, of course, is not parasympathetic. Epinephrine is what? It's sympathetic. And is sympathetic nervous system involved in rest and digest? Definitely. Fight or flight, good. So epinephrine will actually also suppress the stomach's activity. You'll notice the natural orientation of the stomach tends to channel the food down here toward the pyloric region. That pyloric region is where we have most of those gastric pits and gastric glands. And that's where most of our chemical and mechanical digestion is occurring as well. So you'll notice the second phase, called the gastric phase, is covered on the top of page 94. The gastric phase can only occur when food's in your stomach. It can't necessarily grind and propel food if the stomach's empty. So the gastric phase requires for food to be sitting there in your stomach. So notice there's two influences here over that food. Simply, the stretch receptors in the stomach promotes the increase in gastric secretions. That makes sense, right? Because it's like the longer you chew your food, the more moistened it becomes. Likewise, in the stomach, the longer you churn your food, the more secretions you're going to need to break down that food. Notice the other bullet point listed there near the top of page 94. It starts, alkaline pH environment. Alkaline means the pH is where? Yeah, high, like above 7, right? So if you have an alkaline environment in your stomach, or if you have proteins or caffeine enter the stomach, those things will all prompt gastrin to be secreted. Gastrin prompts the release of what? Gastric juices, one of which is hydrochloric acid. Hydrochloric acid is necessary to convert pepsinogen into pepsin, and that starts the breakdown of those proteins. So you'll notice here any of those types of situations. An alkaline pH, eating a protein-rich meal, or caffeine in your diet will all prompt the secretion of those acids into your stomach. We'll come back to that in just a minute. Let's go back here. Okay. We've got two sphincters. We've got the cardiac sphincter, also known as lower esophageal sphincter, up here between esophagus and stomach. Down here between stomach and small intestine, we've got that other pyloric sphincter. The pyloric sphincter now is going to play a role in the intestinal phase. As the food is turned into a soup-like consistency known as chyme, the stomach actually propels around 3 milliliters of fluid at a time through the pyloric sphincter and into the duodenum of the small intestine. 3 milliliters? Boy, that would fill about a test tube. That is not a whole lot of juice, so it's teeny tiny amounts of juice that are propelled through your stomach and that pyloric sphincter into the intestine at a time. Here's what the intestinal phase does. We know the first two phases stimulate stomach activity. Does the intestinal phase also stimulate? What does it do? Decreases and inhibits stomach activity.
For absorption.
Yes, for absorption, exactly. You ever been riding in a car and everybody starts to slow down and it's almost like everybody moves forward and then they all move backward at the same time, kind of like that ricochet activity? That's what happens here in the stomach. As we start to move forward through the stomach and small intestine, it's going to slow down and everything is going to kind of ricochet backwards. So as the 3 mils of chyme are propelled through your pyloric sphincter, that pyloric sphincter tightens up, and then all that forward motion propels that content back into the stomach. That actually does a couple of things for us. It promotes the stomach to continue doing what? Digestion, yeah. Using that acid to help break down that food. It also gives your duodenum a chance to do what? Absorb what it has. Because if you flood all the stomach contents into the duodenum at once, notice the diameter of your duodenum is much smaller than the stomach. You can't possibly absorb all the nutrients out of that chyme. So 3 mils of fluid called chyme at a time are propelled through that pyloric sphincter into the duodenum. And then you've got this ricocheting backwards propulsion that keeps that pyloric sphincter shut and moves that food back into the pyloric area of your stomach. That way we continue digestion in the stomach and give that duodenum time to do the absorption. So the intestinal phase here is actually an inhibitory phase for the stomach. I also want to mention to you something called the enterogastric reflex. You see it in bold there near the top of page 94. Okay, entero means intestine, gastric means what? Stomach. Notice that this is a reflex, so what is not involved? Your brain. Your brain has no control over this issue. This is a set of neurons built here around the stomach and the pyloric sphincter and the duodenum of your small intestine that regulate the emptying of your stomach. This is such a complex network of neurons. Some people even call this reflex a cunning brain. It is that complex and it's that controlling of the environment, so we regulate the movement of food from stomach into small intestine.
So you say when it goes like back and forth like that sphincter is still closed? It doesn't go past the sphincter?
Yeah. It'll squirt a little bit past the sphincter, 3 mils at a time, and then it goes back. Yeah. So the 3 mils is let through, so we've got 3 milliliters of fluid down here, and the sphincter tightens and it keeps the rest of the chyme in the stomach. So it'll squeeze again and squirt another 3 mils through the fluid, through that pyloric sphincter, and then it'll squeeze tight again, and the rest of the fluid will back up in the stomach. So it's working on only letting 3 mils at a time through. There's actually a stomach pacemaker people can get implanted. Did you know that? You can get a pacemaker for your tummy. And what it does is it can not only help regulate the passage of fluids out of your stomach, but it can also make you feel full. So, this is one of those new things on the market nowadays where they can implant it into your stomach. As you eat a little bit, it sends stretch receptor messages to your brain and tells your brain, oh, I'm full, even though you haven't eaten a whole lot. The reason this is actually a good thing is this type of surgery can be very dangerous. Gastric bypass actually snips off most of the stomach, bypasses the stomach and connects it to the small intestine. That way most of your stomach's activities don't have any role in the breakdown of food. So we don't have the acid, we don't have the pepsin and protein breakdown, so most of the activity is given into the duodenum of your small intestine. This is a dangerous surgery to have. You know, you've got essentially a dead organ in here that's not really doing anything. It takes a long time for the stomach to realize it's no longer functional. They have to actually vent the stomach so it can gas off to the external environment. So, you know, the pacemaker seems to be a more recent trend in the way to control people's weight. It's actually making you feel full, even though you're truly not.
Some of them still gain weight like that.
Some of them do because they learn to ignore that stretch response. Yeah. And like with that one as well.